All right. So check-in number is here 1893. I'm starting my lecture now. So 1893. So 1893. Yeah. So we did learn just one method about a weight unit cluster using this formula in the last week, and we did one quiz. So we did go through the quiz and all the information, the video recordings and the detailed annotated lecture notes is already posted on the Blackboard. If you still need to review something, go ahead to do it. In this class, we will skip the adjustment class for the estimating. So that will be very, very challenging one. So we skip that one. So since we used the table with different previous project for estimates, so we're going to starting another one, which is called the unit cost adjustments. So that is using the same information from your previous table. Okay, so for example, here is give an example here, and then we'll do a practice. We'll jump back to the previous one and see how to do it. So for the given cost information from five previous construction projects, right? This is the apartment. And showing the next page, and please using the estimates, the unit cost for new apartment project for 117 units, and using the given data. So if you look in this table, you already know how to use the weight unit cost to do it, right? Because first you are going to determine the cost per unit, which is unit cost. You have those over here, and then you have a total over here, and then you divide it by 5 project here, you get the B, and you find which is A. A is a minimal one. Minimal is come from here, right? And which is C. C is the maximum one. C is come from here. Is that correct? So that is the weight unit cost method. And then you determine the UC is A plus 4B plus C divided by 6. And your times with the requirement is 117. You get your unit cost, right? Does that make sense? So when you look in your homework assignment 1, and your question 1 is the weight unit cost, and your assignment 2 is different, right? So some of you may already did your assignment question 2, assignment 1 question 2, and I told you hold it because we're not teaching it yet. So today we're going to teach you another method, which called unit cost adjustment. Make sure the name for this method is called unit cost adjustment. So unit cost adjustment is still using a table like this, but the sense is really, really, really different. So let me explain to you. So please open your computer and make sure you are on that page. And also make sure you have a paper or either your iPad available now. We are going to starting with this one. So I do believe that is really challenging one because we were using the similar thing but really performing in different ways. Okay, so let me get a screenshot for this one. This is lecture notes 2. We will do lecture notes 2 in the following 2 weeks. Okay, so we still have a lot of work to do with it, so we're still over there. Is that clear to see it? Okay. Let me go ahead to using the iPad here to get access to that one. And please open your computer. You are easy to see it in front of you. All right, so I have this one open here. We have 5 projects, and our total cost is given to here, and the number of unit is given to here. And the cost for each unit, cost per unit is given here. So if you look in the unit for the dollars, it's $1,000. It's not like $1, okay? So for given this one, if our requirement is to using the methods for the unit cost adjustment. So we call unit cost adjustment. It's not with unit cost method, right? So in this case, we are looking maximum and minimum. It's not from the unit cost per unit. We're looking the max and minimum is from here. So find which one is maximum, which one is the minimum. So you have the smallest one is 16. You have the largest one is 190. Okay. So you can write it here. Here is minimum. Bless you. And the 190 is maximum. Challenge. So do you guys understand what is this? Do you understand what is this? It's equation means y is equal to ax plus b. Does that make sense? So the a is for this and the b is for here. Any question for that one? You guys don't know about this? Seriously?
Probably do.
Probably do. This is a middle school.
It's the slope,
I think it's elementary school math sense.
it's like the slope intercept formula. The equation. Yeah, he just has a.
Whatever you want bx plus a. It's same way. Yeah. So I'm using the ax plus b, or you can use b0 x plus b1, something like this, right? So let me write down well. Okay, so that means a relation between x and y. Okay, so in our case like this one, if we do the plot for that, it will be looks different to this one because remember, you're going to the supermarket to buy something. If you go to a Walmart, you buy a pineapple, maybe $3, right? But if you go to a wholesale club, you buy 10 pineapples, maybe $10. So that means when the sales is increased, the product's number increased, then your purchase total cost may increase as well, but your unit cost may be decreased. Does that make sense? Because you buy more and they give you some discount or something, right? So that is the same case. So if you're going to do apartments, only 10 units may cost you $1,000. And if you do 100 units, may only cost you $8,000, right? So that is the unit cost is changing. So I'm giving this plot over here is just for like you to remember the equation over here. But in this case, let's do a plot. So do you guys know how to putting out those points into the plots? So let me clarify. So this is X. The number of the unit is X. And the unit cost for the cost per unit is Y. So we're not dealing with this. So this is only the one we're going to getting the Y, getting the cost per unit. Okay? So don't be confused about the total cost. If you use the total cost, then you will get it wrong. So your X is number of units. Your Y is your cost per unit. So if we have a plot over here, so this is your X, this is your number of units. And this is Y, your cost per unit. So the reason I want you guys to find which is the minimum number of unit and what is the maximum number of unit, because you need it. You need to define the maximum here you have is 190, right? So probably you need to have 50, 100, 150, and 200. And if you look in the cost per unit, you have 70, 18, 20, 24, and 22. Then you probably have something like here. Here's your 5. Here's your 10. Here's your 15. Here's your 20. And I needed to extend this one to 25. All right. So does that make sense? I'm just in finding the largest number from here and the smallest number from here. So that is the same we are going to use next. But for this step, the really important thing is define your max and minimum for the unit cost. That is a key part. So the number of unit is a key part. The max number or the minimum number for the unit is a key part. Okay. So now we're going to putting out this data into this plot. So the first we have 101. So for project A, we have 101. And we have the unit cost per unit is 22.5. 22.5 is here. So 20. Does that make sense? How to make this points, put the point into the plot, right? So the second one is 16. 16 is looks like here. And the 16 have the 24, so it's nearly 25. So I'm going to remove this one. The 25 is close here. Does that make sense? So now we're going to find the next one. Next one is 120, and the number is 20.56. 102 is like here, and this number is like here. Okay, so we continue doing the next one is 150 and 18.20. So 8.20 is here. So the next one we have is the last one. The project 5 is 190 and the 1790, right? 1790. Okay. So now you have all the plot looking like this way. So that is very different to that one, right? This one is kind of like the increase, and this one is likely decrease, right? Does that make sense? So now we can draw a straight line to go through all the point as much as possible. Because if you do a straight line, you may not able to pass out those points because they are not really fall into the equation. Some of them may have some differentials, right? So okay, give me a second. Okay, so I'm going to draw a straight line. I'm trying to pass them as much as possible. So something like this, right? So maybe I need to move a little bit down, but it's fine. So we can see this equation is going down tradings. If we increase the x, so the x for here is the number of the unit. If we increase the number of unit, and then you will see your y, which is the cost per, the y is what? The y is cost per unit is going down. That means if you have something more than 200, maybe 300, then your cost per unit may be less than 60, right? So that is going down a trillion. So for example, you can have here. So if here is your 300, and then you can link here, you can find this. It's even how less than $15 per apartment unit, right? So $15,000 per apartment unit. So we needed to find the y is equal to ax plus b from this plot, and that is equal to find what is a and b. Does that make sense? Because you know the x and the y, and we're going to find. So we need going to find the ax plus b. That means we need to find the parameter a and the parameter b, or variable a or variable b, right? So how to do this? We already defined over here, we have the minimum here and the maximum here. So the reason we want to define the minimum and the maximum here is because we know the minimum 16 is a unit, minimum 119 is a unit. So that means our data, our available data is in that range. So we have 16, we have 119. So that means for a given project, fell in this range, 16 to 19, then we're able to do the estimates. If the new project is without in that range, that means it's either less than 16 or it's more than 119. Using those data, we may not able to give an accurate result. Does that make sense? So that is the reason we need to find in the minimum and the maximum to make sure we're using those 5 data to make the estimate. We are getting more accurate results because our estimate is trying to get it as accurate as possible, right? So so in another way, it means if we're given a project, proposed project falling in this range, then we can do the estimate. So remember, so this project is giving you a new project is how many units? Yeah, take a look in the first page you have is 117 units. So this is your new project. Is this 117 fall in this 16 to 119? Yes, it's probably over here. Is that correct? And that means if we define this straight line by y is equal to ax plus b, then we given a 117 here, put a 117 to here, right? And then we're able to get this y. Does that make sense? So once we get this y is the cost per unit. and we're using this y times with 117, we're getting the total project cost, right? So so I'm continuing here. So once you find the A and B, and then you can use the y is equal to A times 117 plus B, and you get a y, and your project cost is equal to 117 times with y. Does that make sense? Because y is cost per unit, and we know our unit is 117, and then our total project cost is 117 times with unit per cost, right? So cost per unit, sorry. So since we're understanding the relation over here, now we're going to solve the problem. So to solve this problem, you need finding two data sets. Why? Because in this equation, you only have two unknown numbers, which is A and B. For the Y and X is already given by these 5 projects here, right? So to finding the two unknown parameters, as we mentioned before, we need to using this smallest one and this maximum one, right? So that means the corresponding y will be this one and that one. Does that make sense? So we will have the two data sets here. X1 is equal to 16, X2 is equal to 119, right? And then the corresponding Y1 is equal to 24.75, and the Y2 is equal to 117.19. Does that make sense? Oh, yeah. Does that make sense? Oh, 117 from your first page of this problem. The project statement, the case study statement. Right? So since we know this one, we know that one, and we're going to solve the y is equal to ax plus b. So how we do it? So we can get 24.75 is equal to a times with 16 plus b. And one, can you follow this one? Because I put the x1 here and the y1 here. And then you have this 17.19 is equal to 8 times 119 plus b. So does that make sense? Just putting the number in. So x2, 119, a plus b is equal to 117. Oh, sorry, 17.19. This is for y2. So you get these two equations. So how to use these two equations to getting your a and b? Elementary school math. Sorry. So you are define this as your equation 1 and this your equation 2, right? And you are using equation 2 minus your equation 1. Is that correct? And then you do this, you will get 24.75 minus 17.19 is equal to 8 times 130. So I don't have space, so I remove the 119 minus 6 is 130, right? So then you get your A is equal to what? Give me a number. Your A is equal to You get the same number with me? 0.015, sorry, 527, right? I cannot. Yeah, I can write down here. Do you get the same number? You can come here to see, yeah. What question, Harry?
Yes, he said.
Can you remove your headphone? Yeah.
He said.
No, I mean, can you totally remove it?
Right.
No, you need to respect me, okay?
Attention, I have to ask you a question.
You put your headphone in and you say that is respect your instructor and you far away from here. Okay, go ahead with your question.
Yeah. 84.75 plus 17.50.
What?
Add those together or subtract?
Subtract. Subtract. So I prefer.
Why does it say?
This is subtract. Yeah. Can you say? Okay, so yeah, so I give some suggestions for you. First, don't put your headphone on. Second, don't sit over there.
I'm right here. I can tell that subtract. I'm not gonna lie.
It looks like an addition.
It does.
No, it's not addition. This is 117. Yeah. So all right, you get a B here, right? So can you go ahead to find a B? What is the number for B? What is the value for B? Since you know A.
Oh, wait, what time up?
Say, can you find the B? Since you already know A is this small number, can you using the A to find the B? It's very easy. You can put in the A back here, or put in the A back here, and then you can get in the B. Okay, so you can use either equation 1 or equation 2, and putting your A back, you are getting your B. So the number of B should be more than 25, something like 30 something. I forgot number. We can find it together. So so now you already know your so I'm going to remove those. This is users now.
It would be six. That's right.
Okay, now we are going to using the A here to find the B. So if we're using the equation 1, which one?
Right here.
Yeah.
Not in it. It's just the-
Okay, let me do it again. Guys, pay attention. How I get A, I will do it again, okay? Okay. Yes. Yes.
Why does it say?
You are getting the same thing. You can
It's a negative number.
yeah, my bad here. So this is equation 1 minus equation 2. You can do the same way. You can either use equation 1 minus equation 2, okay? So it doesn't matter. If you're getting the minus number, that way will be changing. Let's do it again. So if we're using equation 2 minus equation 1, so this should be 1 minus 2. This should be 1 minus 2. So if we're using equation 2 minus equation 1, so we get 17.19 minus 24.75 is equal to A times 119 minus 16. Right? Is that correct? Okay, so my bad here, it should be -1. So this will be negative here. So we're getting here, then we can find the left side is equal to 17.9 minus 24.75. And we get here is negative 6.185 is equal to 138. Is that correct? So you get A is equal to negative 0.257. All right. So if we're using equation 1 minus equation 2, and definitely you are getting the number looks like 24.75 minus 1719 is equal to 8 times with 6 minus 119. And you're getting A is a negative number as well. So as we can see from here, this one is in the decrease trending. This A should be less than 0. If you're getting the number A is more than 0, that means you're wrong. Thanks for catching this one. Okay, so the A should be a negative number. A should be a negative number. But your B should be a positive number.
Why is B not in that top one?
Which one?
The top equation, the black writing?
You already moved because you only have one B, one B. So that is equal to B minus B. Does that make sense?
Oh, so the whole equation.
Yeah, and this is equal to B minus B. Yeah, whole equation A, left side minus left side, right side minus right side. Okay. I'm sorry, this is like elementary school maths, like 6th grade or 5th grade. So
Too much.
Start to find A, you don't have to find B.
yeah, you find A, then you can use the A to find the B, right? So you find A now, and you will be able to use the A to find a B. So I'll give you 5 minutes to try to find a B. Okay. So it's very easy. Just putting the A back into here, then you will find a B. Or you putting A back to here, you will find the B. And doesn't matter. Doesn't matter. But you are going to see I will putting A back to equation 1 and finding B, something like that. Okay. So I did using the two equation to find the B, which is very close. What's your question? Say that again. This one is a multiple patient size. Yeah, if you can do better, you can put a 16A without this multiple size. So you can change it to 16A. So that is better. Is that better? So so how you get the B? Question for finding B? Any question to find a B? Okay. You all find B?
For which equation?
So no matter which equation you found, you will get a 27.91. Yes. No matter which equation, you will get the same number. So if you use equation 1, you will get a 27.91. If you use equation 2, you will get a 27.913. So
I just put it in
I use it. Oh, it's negative. Yeah.
you get a negative number? No, it's impossible to get a negative number. So this B, remember, if you did a negative number, check it. The B should be a number more than this, the largest number 24. And A should be a number less than 0. Mm-hmm. Yeah, you can round it to like keep 4 digital place is fine. You get a 0.526. I round up to 7.
I got
I'm 5. I'm negative 0.5. Yeah, I'm 5 to 7, not 3 to 7. That is 5. 3 is writing this way. 3 is writing that way, different way. This is 3. This is 5.
Yeah, you are. I'm getting 27.87.
No, you get the same thing. I just think you get the same thing.
What's that my type? 27.87.
27.913.
How you get 913?
Okay, wait. I just read what so that's the part. Out, don't round it out. That's right. Right, it's not the same.
So what did you put in for the time six? Well, did you do negative 0.5? Did you round to it?
No, keep 4 digital please. So for A to keep 4 digital please. Four decimal. So for A, please keep 4 decimal, please. At least. Yeah, at least 4 decimal, please. Yes. All right, since you get A, B, and now can you since you get A and B, can you use your equation to find the Y for a given X is equal to 170?
Why is A positive if we turn that whole equation negative? You get what I'm saying? No, it's not, it's positive. Oh, yeah, 1790 minus 2475.
So now you have Y is equal to
Because we're subtracting the 2 from the 1. So we turn the whole 2 equation negative. Right, but why is A not negative? Stop this. No, the answer to A is negative, but like the A in the problem is not negative. If we turn that whole equation negative. Oh, it has. Why is it negative? Like we turn 60 negative, we turn B negative, but A stays positive. I don't understand. Like, multiply this whole equation by -1. And then just did the minus. That's why 24 turned negative, 60 turned negative, B turned negative, that's why they turned. We multiplied this whole equation by -1.
No.
That's how you change everything to negative. That's why it turns negative and it turned negative to 24. But 8 again, why didn't 8? Everything else.
So this is what I was saying. This product saying is not why you change it. If you mark for those policies, so this one is those
So this is this can just sit up.
because this one shows up.
Right.
Yeah.
That's not. If it's in parentheses, if it's not in parentheses, everything is everything.
Everything is everything. How you
So 68.
You can give the next sign either 60 or negative. If you give this negative sign to A and both 16 and both 3, you can't do it. You see after the 6. Which one match?
Believe that. I'm looking at it, I don't see it. So I see the right name, 86, not 80. For me, from my brain,
so there is a little bit of trick over here. So now can you find the X now for a given Y following this one, and then your project cost will be is equal to 1895 times with 117, right? So this is your cost per unit, and this is your unit. Bless you. And you get a 3221.5. So this is $1,000. The final cost is 3221 per time.
Right, that's, that's your final cost.
For the project.
170.
Yes.
At 18.
Yes, you're right.
Okay.
Yeah. So the equation y is equal to ax plus b is going to find this cost per unit. And you need to using this one times back to get your total project cost. So this is not a challenging math work, but just make sure you getting the correct sense with your math. So there's some confusion over here, 1 minus 2 or 2 minus 1. And I'm not sure whether how you perform it, but in my way is the left side of here minus this left side and this right side minus this right. Some students use a -1 times -1 over here. So if you do a negative, you need to change this one to negative, right? You need to change this to negative, and also you need to change this to negative. So when you change this to negative, this 16a is a negative. But if you given the negative to both 16 and both a, you are getting back at 16 as a positive one, right? So that's
I think maybe I'm just going crazy. Yeah.
Yeah. So since you get it out of me, you can put it in one class.
How did you?
I see.
Oh, never mind.
There was one time that was negative. A is always negative.
Wait, you on? So we're not dividing by. I'll just leave it. That's your final. That's the.
Yeah, that is just.
Saying what he, well, it don't make sense. You can see you get 170. Look, as you can see, and then it's higher than the cost of 150. Dr. You on? How come on the graph, it says 150 is at 1820, but 170 at 1895? How you go up with the graph?
No, we're not go up. Oh yeah, you're right. So there's some of the rubbish over here. You have 150 here. You have 150 here. You have 80.2, right? But when you're getting 170 here, if your calculation is correct, you get this 18.95. You all get this number?
Yeah.
Okay, so that happens because when we're putting the plot in, and you will see that plot is variable between this straight line. We're getting this one is using the minimum and maximum one through the straight line. Let me redraw the pattern. So if we have a plot over here, this is X and this is Y. And our straight lines look like this, right? But our data is actually, does that make sense? Our data is not exactly falling in. Our data is close to it as much as possible. Yeah, and in this case, we're using this one, this minimum one, and this this minimum and this maximum to getting it. So, but our other data may be here, right? So just make sure when you're getting this number for X over here is not bigger than this one, right? It should be bigger than this one because this is the maximum one and also less than this one, okay? But for that very close one, it doesn't matter. But when you change it with this one, 120, you will see it's actually less than this one, right? But if you give a table like here,
Or you can try another way. Can you put in this 190 in and see if you can get this? Yeah. Put a 185.
You get 1790.
1790, right? It's very close to it, right? Yeah. So if you put in 190, you get this one. If you get 185, you probably get a number. Sorry, it should be more than this. 185 is more than this. So any more questions for this method for the unit cost adjustment? Unit cost adjustment. Any more questions for this one? Perfect. So if perfect, we go back to the lecture notes. And what's time now? So it's 9:30. So it's 9:30 now. So I'm going to clean those. And let's go back to this one. So we come back to this one. So this one we're using the unit cost the with unit cost method to do this one before, right? So now we're using this same one, the same table to try with the unit cost adjustment using the y is equal to ax plus b. Does that make sense? Okay, so I give you the remaining time of this class to try this one, and then we will review this one in the beginning of next class, and then we will do a quiz for that. Okay, so
I got something to do.
yeah, you can leave. Yeah, definitely. This one, please make sure you did it before you come to class next this Thursday. Okay, please make sure you did this one when you come to class this Thursday, and we will have additional quiz as well. Okay, and also you can go ahead to try your assignment 1, question 2 using the unit cost adjustment to do it. Okay, so this is your previous case study for the weight unit cost in class. So you can find in this table from your lecture notes, or you can find this one from the lecture notes too. Conceptual estimate.
No, you did not.